Good afternoon from Singapore and to our friends tuning in from all around the world. Thank you and welcome to today's session where we will be talking about 3D printing with generative design that is organized together with NAMIC. My name is Wei Min from SGInnovate, and for those who may know, SGInnovate is a government-backed deep tech investor and company builder whose mission is to help entrepreneurial scientists build deep tech startups that are looking to solve big global problems. Our work also involves building a global community of leaders, thinkers, and doers to drive and scale deep tech innovations in areas such as AI, healthcare, quantum tech, autonomous technology across various industries. Now, talking back to today's event, 3D printing is getting more and more popular with consumers adopting the technology in both personal and industrial basis. While most of us here today should already know what 3D printing is, I actually do wonder how many of us here really understand what generative design is and how can it be a game changer to the Industry 4.0. I shall not embarrass myself by diving deeper into what generative design is, but instead I am sure our speakers today will have a wealth of knowledge to share on this topic. For today's webinar, we also encourage for all attendees to share with us your thoughts on the topic or interact with our speakers by posting your questions in the Q&A tab located at the bottom panel of your screen. Otherwise, feel free to just say hi or do a quick shout out from where you are in the chat box below. With no further ado, do allow me to pass the time to Suchitra Narayan, Director, Venture Building from SGInnovate to kickstart the session. Suchi, please.
Thanks, Wayman. Good afternoon and good evening to everyone joining us from various parts of the world. I'm Suchitra, but Suchi for short, if that's easier. And for those of you that don't know me, I'm a director with SGInnovate's venture building and investments arm. I've sort of spent my career doing management consulting, commercial advisory, acquisitions, investments, corporate partnerships, mostly across Australia and Asia. I also lead the advanced manufacturing sector as well at the moment. So I'm really excited to be the moderator for this session today on 3D printing with generative design in collaboration with NAMIC. You know, I actually moderated another session a couple of months ago on 3D printing, and generative design and 3D printing, in my mind, are essentially two different functions, but we're working towards the same outcome, right? And when the two are put together, the commercial value that can be generated in the market, in the business world, in manufacturing is pretty immense. And as I was looking and preparing questions for this session, I came across a multi-industry report by McKinsey on generative design. And frankly, quite amazed to see that the generative algorithms can reduce costs by up to 20%, can reduce the part weight by up to 50%, can reduce development time by up to 50% as well. And in industries such as, let's say, the airline industry, one can only imagine the millions of dollars of cost savings if those airlines could just shed a few pounds, you know, lose 20 to 30 kg even. That's millions of dollars in translation. And so when I think about commercialization and the value proposition, it seems very straightforward. Generative design is very straightforward. It's a non-disputable value proposition. It reduces your lead time. It reduces loss of production. You know, there's job creation in there. It reduces your raw material utilization. And frankly, in these times of the pandemic as well, it's sort of where everybody is localizing supply chains, it shortens your supply chain, right? So it saves on time, effort, cost savings, kind of like a no-brainer. But it does, however, generative design does need to be supplemented with the low-cost, efficient capability of 3D printing, producing the cheap and strong parts for the prototyping as well. And for additive manufacturing to be successful, the input design into the printer has to be successful as well. So it was fascinating, right, to look at, you know, what are all the consideration sets, the load, the strain, the material, the manufacturing output, all of which could lead to not just different options for people in terms of design production, but really non-intuitive solutions. And that's pretty amazing. So I can go on and on because it's a fascinating topic, but I'm not the expert. So let's hear from the experts on how these two technologies can actually bring about greater outcomes to all. So experts, may I request you to unmute yourselves, and let's start with a round of introductions of our speakers. Tell us a little bit about your company, your role, and sort of how your role applies generative design or 3D printing in your field of work. And could we get started with Serene?
Yep. Hi. Thank you, Suchi.
Hi, Serene.
Thank you for having me. And good Friday afternoon to everyone. And my name's Serene. I'm the Managing Director for Autodesk in ASEAN. I'm responsible for driving Autodesk business strategy and market expansion across all sales channels and accelerating the subscriber growth for our most extensive portfolio, which is 3D design solutions in ASEAN region. So what does Autodesk do? We are different. Autodesk helps customers to get on their digital transformation at their pace and deliver outcomes for our customers. We have deep domain knowledge. We have been in this business for almost 40 years, from styling to engineering to manufacturing to managing all sorts of the processes. And we do this with the most modern technology, cloud, connectivity, easy access, and data at the core of our platform. So we are providing the industry-leading platform for both design and make. So generative design in Autodesk is a very interesting topic and inspiring as well. It's in Autodesk is 100% automation, yeah, and we leverage AI, artificial intelligence, machine learning, and we are tapping into the unlimited cloud computing power, where the design team or engineers are no longer limited to the constraint of their own imaginations. And generative design gives customers the chance for innovative solution with much higher performance, like what Suchi had said just now. Yeah, and it free up the engineering resources by automating the process of innovations and the product development. So why I say that we are Autodesk, we at Autodesk are different, because Autodesk set this up in a new way, and we help both enterprises and small company to deliver a world-class customer experience. So it is not just about innovation, it's not just about automation, it's a true differentiating factor. So in my view, generative design will become an integral part of the life of an engineer to shape the future of product development. It is vital and yet invisible.
Thank you, Serene. Marta, can I ask you to introduce yourself?
Hi everyone. My name is Marta Cherednik. I'm originally from Russia, but my design studio is based in Australia, and I'm currently in Singapore. So a little bit of geography here happening all over the place. So my studio is focusing on design for 3D printing, and we do lots of home decor, we do fashion accessories and little custom projects. So customers come with absolutely different ideas, and we help them to bring that to life. So we've been doing it for almost 10 years now. So we've been in the business for a very long time. And we used multiple software and tried different approaches. And for most of the time, since the main style was geometric, so we used one of the most popular engineering software, which is SolidWorks. And that was limiting us a lot into doing just geometric shapes. And then at some stage, what happened and how we came to generative design is we realized that we hit the wall and that's it. So we grew out of the box and we need to keep developing. So our ideas, we couldn't any longer feed them into just a geometric shape. So we started looking at other programs like Rhino and Grasshopper, and that's when the magic happens. So I've got a background in science and in geology. So I've got lots of knowledge in crystals and dendrites, and just about 6 months ago, we started developing a collection which is based on really complex shapes, and that's definitely something that requires generative design. And this tool allowed us to make this ideation process much faster. So of course we do it as always, first on the paper, some general ideas, but then you spend some time to set up, and then yeah, magic happens. So you get lots of different variations, and then you can pick, and that saves you definitely lots of resources. And for a small company and a small studio like ours, this is really important. So one of the latest projects is this one. So you can imagine creating a series of these ones would be really difficult if you just do it one by one. They all look like plankton, they have really complex shapes, but if you use generative design and you set certain parameters, yeah, you can come to that collection much faster, and it still looks amazing. So that was our way towards the generative design, and to be honest, we can't look back at the moment.
Thank you, Marta. Nice little plug there, like that.
Thank you.
Over to Lynn. Could we have you introduce yourself? I'm just going in the sequence that I can see videos on my screen.
Fantastic. Yeah, thank you. My name is Lynn Kaiser. I'm a German entrepreneur. I've been an entrepreneur for 30 years. Did lots of different things. Started my career in industrial automation, back in the 1990s. Then did image processing for Hollywood, in the 2000s, the early 2000s. We helped digitize the film industry using GPU processing, image processing. And yeah, in 2008, Al Gore held his famous speech, An Inconvenient Truth, and it kind of alerted me to the challenges that we face as humanity. And I wanted to do something else. And it took me a while, but in 2011, 2012, I stumbled upon 3D printing. I've been doing software all my life. I started coding when I was 8 years old. That's a long time ago now. And I witnessed the entire PC revolution. And for me, in the PC revolution, innovation was always extremely fast. If you think about it, 10 years ago, almost nobody had smartphones. 20 years ago, almost nobody used the internet. 30 years ago, only a few crazy people had PCs. But if you look at physical objects, they don't evolve that fast. If you look at a gasoline car, if you strip away all the plastic decoration, it looks like a car from the 1980s. So why is that? A lot of the challenges that we face as humanity, they have to be solved by physical objects. And so if we continue down that really slow innovation route, we're going to run out of time. When I discovered 3D printing, I realized that this is probably the answer, because 3D printing gives us the flexibility to produce objects in a very, very creative way. It's basically printing code. So I was wondering, can we bring the speed of Moore's law into engineering and then use 3D printing to actually output these things? And that's what we're doing with the company I founded in 2014, a company called Hyperganic. So what we are doing is we create objects using code, using algorithms, and then we produce them in digital factories that have 3D printers at their heart. And I believe it's a revolution in the way we manufacture things. I don't think we've even scratched the surface of what is possible. And it is my mission to actually push this forward at unprecedented speed. So this is really what we are doing. We have a significant team here in Singapore. The company was started in Munich. But last year we started engaging with NTU and then started building up a team in Singapore. And we are now seeing the fastest growth in Singapore because this country has really made it a mission to innovate very quickly, especially in the manufacturing space. And yeah, I mean, our company is still a startup. So we have about 30 people, just closed our first real financing round. I financed the company more or less myself in the past years. We sold our last company to Adobe Systems, back in 2011. So that gave us a little bit of cash. But now we are planning to grow significantly, especially in Singapore, and we're hiring. And yeah, our mission is to fundamentally change how engineering work. Engineering is today mostly a visual thing. So fundamentally, it's a little bit like Leonardo da Vinci did his designs. You know, you come up with something crazy in your head, and then you put it on paper. And today, you don't put it on paper. You instruct a computer to do it. You know, but it's still kind of a visual process. What we do is we move this all into algorithms. So instead of coming up with one design, you come up with an algorithm that creates designs like that. And in these big solution space, in these lots of designs that your algorithm can create, you know, there's probably one that is optimal and that is amazing and that, you know, pushes the boundaries. And, you know, one of the objects that you see in my background is a rocket combustion chamber that we did in 2018. It is an object that was not created visually and then optimized. It was an object that was created from scratch, completely using AI and algorithms. And the advantage here is that you are not constrained by what you can imagine. You're just constrained by what you can encode in terms of possibilities. And we believe that, you know, in the next couple of years, the shape and the functionality of physical objects will dramatically change, just like, you know, things changed when the microchip was invented. You know, if you think about it, a microchip is a printed computer, and now we can print almost any machine. And we work all over the world with customers in aerospace, you know, in medical field, but also in consumer goods. So it's a lot of fun seeing, you know, what's happening in our WIP channel every day. And, you know, it makes me very hopeful that we can actually, you know, get to the level that we need to get in terms of innovation to solve humanity's greatest challenges. So that's about me and Hyperganic.
Thanks, Lynn, and congrats on the fundraise. So those of you in the audience who are looking for a job, probably in generative design, you know, reach out to Lynn at the end of this session. Mitchell, over to you for an introduction.
Yeah, thank you, Suchi. And firstly, I just wanted to thank you and the NAMIC team and SGInnovate for putting this together. Really appreciate you guys inviting us. So thank you. And thanks to the attendees.
To have you. Thank you for being on as an expert speaker. You know, our audience is very excited to hear from all of you.
Yeah, no, thank you very much again, and thanks to the audience for spending the time. Hopefully it's useful. So my name is Mitchell Burness. I'm the head of go-to-market for a company called HP. Now, those of you who are unfamiliar, HP was founded in 1939 by Bill Hewlett and David Packard, and our organisation is very strong in 2D print, as you may be aware. And about 4 years ago, we leveraged a lot of our capabilities in 2D print to develop three-dimensional printers. So my role is for our hardware, our software, our services, and also all of our consumables across the APJ region, including Japan, China, Korea, India, Southeast Asia, and South Pacific. And as you can see in my background, I am also based in Singapore. Yeah, my interactions with customers, you know, to answer your question, how do I interact with generative design on a day-to-day basis? Our technology is highly capable for an output device, effectively for all the great software design and work that a lot of our customers use. They are always looking to, as Lynn mentioned, create a physical good. And I think this is the important part that we play as HP in this value chain, is to provide an output device. And we're very focused on bringing those technologies to market globally with new materials, applications, and ways for these amazing new designs to be, I guess, developed, for want of a better term.
Thank you, Mitchell. So I thank you all for the introductions. And what I'm going to do is start with a couple of really broad brush questions. I have some questions for each of you on the panel, and then I'm going to open up to Q&A. So audience, please do put your questions on the Q&A box, and we will get to it, because this session honestly is for you. So at a broad sense, and this, you know, Lynn sort of alluded to it, but in a broad sense, how do you think generative design can actually shape the future of product development? And at what point of the value chain does 3D printing really start to supplement that generative design?
Who is the question for, Suchi? Sorry.
Absolutely anyone.
I will have a go, right? Because for me, when I learned about this technology, it was, I'm an industrial designer by trade, and we referred to it as rapid prototyping. I'm showing my age a little bit, but it wasn't known as 3D print at the time. And in terms of adding value into the chain, it was always about during product development and iterating quickly, testing designs before going to traditional manufacturing technologies. And obviously in the last, I guess probably 6 or so years ago, this term of 3D print came about, and immediately people started to understand, and it resonated a lot more with people, this concept of 3D print versus rapid prototyping, which sounds quite nebulous and difficult for the majority of people to grasp. And so at that time, there was a real push and drive to move up that value, or move along that value chain, I should say, into more production related processes. And that's really a big push for HP, and why I joined HP when we started about 4 years ago is this push to move along into production end use components. And that opens a lot of great opportunities, of course, which generative design can help to develop. So that's my quick answer. I believe there's a lot of new value being created with these types of new design approaches.
No, additive is the absolute enabler for generative design. You know, if you think about traditional design and traditional engineering, when you want to produce a widget, you always also have to design a machine that produces that widget. And that limits innovation in a tremendous way, you know, because whenever you want to change something, you also have to think about the production process that has to change. You know, at the very minimum, you have to create a new tool. Sometimes you have to build a completely new machine. So there is no, it's no surprise that you know, people try to keep everything as it is. Like I said, you know, I mean, look at most machines out there, and they are derivatives of the stuff we did 100 years ago. So additive doesn't, you know, a 3D printer doesn't care whether it prints the same thing or something else, you know, so you can change whatever you want to change, and you can just output it. We did a case study with a bicycle helmet, you know, and the bicycle helmet can be adjusted to your specific head. I don't know if anybody here has a bicycle helmet that fits. I have never seen one, because heads are very different. And you know, people try to do it with padding and all kinds of things, but imagine just scanning your head and then creating a bicycle helmet that actually fits. So that sounds kind of obvious, and you know, it's a great use case, etc. But let's take it a step further. So imagine you know, you had a bicycle crash, you know, and you fall on your head. And the manufacturer actually tells you, okay, you can send back the helmet, and you know, we'll give you a discount on your next helmet. And you actually take the crash data and you look at, you know, how that helmet actually performed in the crash, and you feed that back into the algorithms that actually create the helmets. So the next helmet that is printed can actually take these things into account. So it's not like, you know, product cycle that maybe 2 years, 3 years later, you know, this comes into play. You know, it can be done immediately, and we all know that there are regulations and stuff that need to be adapted. But this kind of shows you, you know, how quickly this thing can evolve, and the additive process is the enabler for it. I mean, the best example for additive is actually nature. You know, nature optimizes every single object that, you know, it creates. A tree is perfectly optimized for that specific location, and each new tree is more optimized than the tree before. And the tree works by placing atoms in space, you know, when it grows, and that's an additive process. So it's exactly what a 3D printer does. So that's, you know, if we replicate that, you know, we can open up engineering to basically, you know, the complexity of nature, and, you know, to the optimization that we see in nature.
I also would like to add on to what, you know, both of those gentlemen had said. Certainly, in my view, 3D printing is of value in 3 areas, apart from prototyping, the traditional approach. I think manufacturing of those low volume and the high performing parts are also very useful. And you look at, you know, when you do an on-premise or the replacement of the part, manufacture the spare parts, and you can use the 3D printing and to avoid production stop and the shutdown. So when you combine generative design and 3D printing together, industry where they have the need of low volume, the high performing parts like auto, aerospace, maritime industry, with the spare parts that needs like transportations, or in the high-tech industry in a remote location. And this kind of method will help you to accelerate the whole process of your productions. So this is also another area where we find that 3D printing will be able to help, you know, to improve your whole entire throughput and output for your production to make it more efficient. And you're leveraging on the technology to do that, to imagine what it's like. So another area that we look at is, to the point what Lynn was talking about, is really the smart products. The smart products that you build through this method of additive manufacturing or advanced manufacturing, they embedded the chips, electronics, you bring it all together. And they'll be able to tell you, hey, I will break down if you don't change my part in 1 week's time. So these are some of the ideas that which, you know, our advanced technology or additive manufacturing will be able to support. These smart products that which become a hot topic, and all customers are expecting that today. And they are expecting to have better customer experience. They're expecting people will be able to tell the improvement through the behavior, you know, using machine learning to be able to pick up what are the shortfall or things area for improvement. Yeah.
And yeah, to add on that, I think 3D printing is also a really great response to mass manufacturing. So I think we all can agree that mass manufacturing just destroys the nature of the planet, and the attitude towards pretty much any objects we have around, they just lose value. So with 3D printing, you can do a very important thing. You can bring back personality to things. So if you create a custom thing for the people, they value it more, therefore they use it longer, and you don't do any mass production, you don't use any storage, so each single product is made to order. So I think 3D printing is also a very good way to fight mass manufacturing.
But can I jump in there for a second? Because Marta, I think when I looked at your website, you know, the thing that struck me the most is the objects that you create are impossible to manufacture any other way but additive, right? So what you're doing is a wonderful example for you know, what is actually there to come. You know, it's yeah. I mean, there are efficiencies, there are, you know, small batches that you can do more efficiently, stuff like that. This is all good. But what excites me personally the most is that we can create stuff that has never been done before. And that opens up such a huge new you know, spectrum of opportunities for engineering that I think it will, I mean, when we look back, we will see this like as a singular moment in history. You know, if you think about it, you know, before mass manufacturing, every object was basically customized because some person sat there and created it for you, and it didn't matter whether they created the same thing or something special for you. So if you're looking at an old building, chances are high that, you know, every window is actually slightly different, and every ornament is slightly different. And that actually makes it very attractive, by the way, as well. And then mass manufacturing came, and then today, you know, if you look at the building, everything is identical. You know, we all try to squeeze our feet in the same shoes. We all try to squeeze ourselves in the same clothes. You know, so it's you know, it's everybody's kind of equal, but not really comfortable if you think about it. And now we have this wonderful opportunity to actually target things for personal things. So this is, Marta, what you're doing. You're basically creating objects for one person, and that person will appreciate this much more. But we can also basically, when we build a machine, say this is a machine for exactly that purpose. It's no longer this one optimized machine that has to fulfill basically everybody's wishes, and if they need something a little bit more, then they have to buy the next bigger machine. So you're always over engineering in today's world, which is basically, Marta, what you said. You know, we're destroying the planet because we're wasting resources. But additive also allows us to move to a different way of thinking. You know, when we create breakthrough innovation, we have to accelerate innovation cycles. So actually we have to throw away a lot of things earlier. So I think one of the key enablers for additive, for a sustainable additive economy, is a circular economy. If you think about nature again, isn't it a huge waste that at the end of the year, the tree throws away all the leaves and, you know, just regrows them next year? wouldn't it be better to create a perfect leaf that can survive the winter? Yeah. So I think what we actually have to aim towards is a economy where we have infinite recycling and where we can innovate quickly and iterate quickly instead of producing objects for eternity. Because producing objects for eternity is actually something that will prevent innovation from happening.
And it's interesting, right, Lynn, because that's sort of where this whole mass manufacturing came from, is that, you know, we don't want objects to last till eternity. But Marta, you know, I have a term coined for this, which is kind of counterintuitive. I call it mass customization. You know, that's literally what 3D printing does. It allows you to customize things, but on scale, right? So you're not building out single solution, redoing the entire design, but yet it's something that is scalable and possible as well. So if we look at industries of adoption, are they? I'm curious because we have startups who are in the audience. Are there specific industries, traditional industries, who are more open to adopting generative designing and 3D printing? I know the airline industry, but apart from that.
Yeah, definitely. I mean, you know, Suchi, you mentioned mass customization, and you know, certainly we've had fantastic success with existing customers using subtractive technologies for mass customization, and a really good example exists. One example is called iOrthotics. You know, they were an organization that produced mass custom foot insoles, and every part they produce is developed for an individual based on three-dimensional scan data in a similar way that Lynn has explained. And these guys have been doing this for some time. They use our technology. And from a sustainability point of view, I mean, they've reduced the amount of waste in their products by over 90% compared to subtractive. They've been able to produce components more quickly, and they've been able to improve patient outcomes. So a really good example there. They now have multiple manufacturing sites globally. They started in Australia, actually, where you've done some work already, and they've now expanded beyond Australia. So this is a really good example of mass custom. And you know, when you refer to some of these sustainability factors, you may or may not be aware that HP has some very ambitious sustainability goals. And one of those actually is to meet a 75% circularity, product circularity of our packaging products by 2030. So we're very much focused on goals like circularity and ensuring that we are providing products that get reused and repurposed where possible. So.
No, thank you for that, Mitchell. That's interesting because, you know, when my kid broke his toe, it's not a traditional plaster of Paris cast anymore. I didn't realize you can actually 3D print a splint, which is open, but yet balances the toe. So he could literally play football while he had a broken toe, which is fascinating. I didn't know that until I went to the doctor, but he didn't tell me he broke a toe for 3 days, but oh well.
I hope it was one of ours.
Oh well. So, I mean, sorry, did you have
Can I add on? I also have something interesting to share when they talk about this 3D printing. Yeah, so we also saw that there's Airbus. Yeah, we all know Airbus, right? That is the pioneer in the aerospace industry. So they are the leader in the design, manufacturing, and delivering aerospace product. They also use 3D printed aircraft cabin component. Yeah, and they use generative design to do their Airbus new bionic partition, and they save 45% lighter than their current weight. So they use combination of both, and it helps to reduce carbon footprints a lot because it reduces the weight by 30 kilograms. Yeah, and that is actually very massive because in the aerospace industry, we all know that they're highly optimized, and reducing weight in a component by 45% is a real breakthrough. And they can do this is to generative design and do the 3D printed aircraft cabin scenario. And obviously how they can do it and achieve this kind of target, because with the technology additive manufacturing with 3D, with generative design, the system come up with a very weird geometry. And that kind of geometry is beyond any human being or engineer that could come up with. Yeah, and they estimated when they apply this to the entire cabin and to the current backlog of their A320 planes that they have, they estimated that this new design approach can save up to 460,000 metric tons of CO2 emission per year.
Fantastic.
Yeah, and that is equivalent to taking 96,000 passengers car off the road for 1 year in Singapore. So you can imagine this is the kind of massive thing that you can use using technology. So, all this technology will be able to create, whether it's a mass production or bespoke parts with very complex geometry, and it creates very little wastage. And so when you have less material wastage, you provide cost reduction, especially for high value parts, right? It is straight away you can see that drives through to your bottom line. Yeah.
But Serene, so let me ask you while I have you on the screen. I mean, so that's the current design, and we know that Autodesk is synonymous with generative design software, right?
Yeah.
Like how do you ensure that your algorithms are constantly on top of it, constantly making the best recommendations, constantly pulling out what is next for your clients? Because Lynn alluded to it as well. He said the image behind him was not something that had ever been humanly created, right? It was created on the software. How does Autodesk really ensure that?
Yeah, that's a very good question. How do we ensure that? Yeah, and additive manufacturing generative design has been one of our biggest focus in the industry, and the requirement and the capability is constantly growing. So our vision is a better world designed and made for all. Our mission is we want to empower all the innovators with design and make technology so that they can achieve the new possible. So we deliver customers intuitive, powerful, and accessible technology that provides automation and insight for their design and make processes so that they can achieve a better outcome. So how do we do it? We have our own research team who work very closely with the customers to constantly evolve with customer what they can do with the generative design. So we even have a generative design field lab in the US. Yeah, and we work together we have an advanced manufacturing facility in Europe as well, whom we partner with the industry top leaders in the UK, who help customers to understand how this generative design can be applied to their processes. Back in Singapore, we have strategic partnership with the Singapore University of Technology and Design, SUTD, and we provide a free access onto the Autodesk newest design technology. Right. Generative design is included, so the students and educational institutions, so that they can access to the tool when they need, even for what they are studying or for need for their future jobs. And we see this as the biggest benefit of generative design beyond just additive design, but even in milling, molding, casting, everything that we are doing. So we see increased interest from our customer to support more advanced capability of 3D printer, as well as large scale and the large volume of the printing, like propeller, maritime, and all those. So in Autodesk, we are always exploring new ways to support more complex design that traditional manufacturing cannot produce. So we also explore a new design with either additive manufacturing or hybrid manufacturing to build a smart product. So we are always working towards this called less is more tagline. With lesser resources, we can still create more. So we see this as a key part of our future of makings, things from design to manufacturing. So we look at new materials, we look at how this will require new manufacturing the methods that we are deploying. So we support many more different technology, and that opens up the door for many more use cases. Yeah, like for example, we have this 2.5 axis of mill parts that connect to a robot with an extruder. Yeah, and that can be designed by generative design in 2 hours instead of the typical 6 hours manually. So we believe that our strategic partnership and engagement with customers, the industry leaders, the external research firm, and our own internal R&D focus and our continuous investment that help us to stay ahead and set the industry trend. So we put in a lot of effort in there. We have a dedicated team, do nothing and just keep thinking of what's next, what are the newest stuff. And we got a lot of feedback from the client.
Can I jump in here? Because I just want to make sure that because some of the questions in the Q&A also go in that direction. One of the things that concerns me a little bit is, when we talk about generative design, that we are talking about incremental improvement of existing designs. And this is a really, really important part of it. Topology optimization, these kinds of things. I mean, basically what you said with the the cabin separator.
Yeah, the Airbus.
Interesting stuff. But, I mean, I just want to make sure that people understand the fundamental change that is happening. These are kind of the low-hanging fruit, right? So it is, I'm entirely sure that in 5 to 10 years, we will have algorithms that don't design an air cabin separator. They will actually design entire components of the aircraft, maybe the entire aircraft itself. And if you say that today, people are smiling and say, wow, such an aircraft is a really, really complex thing. And, it's really, really complicated. But if you look at software today, software is the most complex thing that humanity has ever created. There is software that can fly airplanes. Why isn't there software that can design airplanes? I don't think it's more complicated to design an airplane than it is to fly an airplane. So I just want to make sure that everybody understands how fundamental this change is that is going on here. It is not about incremental improvement. It is about a fundamental new way of designing things. And at first, we are going to design small things, small subcomponents, but more and more, and that's the power of software, once you've designed an algorithm that creates one component, you can create another algorithm that designs, that combines multiple of these components, and you're building on top of everything that's built before. Yeah. In traditional CAD, this is not the case. In traditional CAD, you're always starting from scratch, more or less. And that's why everything is like incredibly slow. Right. So this is the fundamental change. And if you want to understand how fundamentally different this is, just compare a bird to an aircraft. Then you know how far we actually still have to go as humanity in terms of engineering. Yeah. There will be a time when we can design something as complex as a bird. Not tomorrow, not in 2 years, 10 years, maybe 15 years, definitely. And this is the goal of our company. What we've created is a technology that can basically place atoms in space. This is the fundamental innovation that we did. We said we want to be able to represent geometrically everything that a 3D printer can output. And that basically means, I have to address every little particle, give every particle, process information, material information, etc. And from that, I can build anything. And now it's just a question of the algorithm that I attach to this magic brush that paints atoms in space that makes it a rocket engine or a bicycle helmet or a medical device.
That's a great point, Lynn. It's a great point that it's not an incremental technology. And I think at the fundamental, the word it's not incremental hit home for me personally from that comment. And it's interesting because Marta, I mean, you're a designer, right? You're doing that. You're doing non-incremental design, essentially your products. How do you draw the link between generative design and 3D printing for production of your products?
Sorry, say it again. How do I?
So you're sort of doing that, right? Everything that you're producing is not an incremental design. It's something absolutely fresh. It's customized. It's creative. How are you drawing the link between, the creative process, the generative design, and the 3D printing, and bringing it all together as something completely unique, as a non-incremental solution to market?
Yeah, that's a combination of all of the above. So I've got a really strong belief that if you want to create something new, you have to take something old, something really new, and create something in between. Because people are really afraid of new things. They're reluctant to even approach it. So they're not going to go for it. Too old is too boring. Something in the middle, that's what people are interested and not afraid to do. So like Lynn said before, that's actually the main philosophy of the company, is creating objects that cannot be created by any other type of manufacturing, because I believe that 3D printing should be used correctly. I've seen so many examples when it's used so wrong when you can see absolutely flat parts that could be used by stamping, by injection molding, and other means, and you just look at it and you understand, okay, that was a waste of time, of material, because you can easily do it the other way. So with 3D printing, the whole idea in our studio is to create things with really complex shapes. And in terms of engineering, I think it's a great opportunity to actually reinvent the wheel, because that allows to create new mechanisms. For example, I've got already a few bags that use buckles and opening mechanisms that's not used before, just because of manufacturing constraints. And now you're able to create parts that are already interlocked. So they go straight to the machine and they come out of the machine, no assembly needed. So the maximum you need to do is to apply some color or some finishing or change the surface slightly. And that's the main philosophy that we have to actually produce things that are impossible. It's like inventing 6 impossible things before breakfast. Actually, really good exercise. And in terms of creativity, so I was leading, they were not courses, they were more of a marathons about creativity, because and imagination. So lots of people have a belief that it's a talent. Creativity is not a talent, that's a skill. And you can easily learn that. And I have a very mixed opinion on generative design, even though I use it myself. At the same time, it could be a bit dangerous, because people can slowly lose that ability to think creatively. Because to think creatively, you need to do exercises. You need to exercise it every day. And then if you have machines doing that for you, people might relax a little bit.
It's frozen.
Oh, is it frozen? Yeah, I was.
Yes,
I
okay.
just,
Yes, you're back. We can hear you.
yeah, okay, good, because I saw everyone else was frozen.
Can I very briefly jump in? I don't want to monopolize this, but this is a really important point. I think generative design, if applied correctly, is an incredible tool for creativity. Now, I mean, I think the best example that I have is the smartphone. I mean, it used to be really complicated to do photography. And I think it limited a lot of people's ability to express themselves through photography, because you have to learn all these techniques, have really complicated equipment, expensive equipment, etc. And now everybody with a smartphone can actually take amazing pictures. Now, if you look at it negatively, you can say, "Oh my God, yeah, but the skill is lost," and people are just applying the same technologies everywhere, and all the pictures look the same. But what you see now is that some people who would have never touched a camera before are expressing themselves creatively through this new medium. And so I think, I mean, to me, software is one of the most creative things you can do. And I think software connected to a physical output device is incredibly powerful. So I think we're giving a voice and a way of expression to people who would never have, in the past, would have considered creating physical objects. But I'm completely with you. We have to be very careful that we don't automate away this this expressive part of it. But I've seen amazing things done by artists using our technology. Yeah.
So I think it should be a combination of human creativity and machine creativity. As I said, I always have that rule that when you combine the best parts of different techniques, that's where you get an amazing product or amazing technology. And I think they should go in parallel. So it will, generative design, I don't think it will take place of human brains. It will be a great tool, and that's how I see it.
It's a superpower.
Sorry.
Yeah, like having computer to create hundreds or thousands of different design options, right? And you as the engineer or designer, you will come in and will just pick what design, the best design for you, whether it's from a creativity or in terms of different kind of value that or criteria you put into the system. And that's the power of generative design. Yeah, they look at
exactly
alternative that can evaluate the problems. Yeah.
But as a designer, you still need to create that input, because it is up to designer to still look at ergonomics, at how people use products, how do they behave. So all of that information with time, of course, will be downloaded into these algorithms. But for now, these algorithms are not complete, so they will be updating with time. But at the moment, it is still a designer's job to create these settings to ensure, in the end, the software generates the correct design and valid design.
Yeah. And I think it limits it as well, right? To a certain extent, AI already carries the biases. It already carries human biases. It carries our current creativity. And so it has to keep, which is why I asked Serene that question, because we constantly have to keep up with creativity in order for AI to help us be smarter and help us be more creative and design better in the future. But we've heard from the design side, we've heard from the software side. So transitioning this into something that we can touch and feel, Mitchell, I'm curious to hear your point of view about transitioning these creative ideas and these designs into actually applying them on the printer for 3D printing technology, and then we'll go to the open Q&A after that.
Yeah, look, I think some fantastic discussion, and certainly sources of creativity and biomimicry, as mentioned by Lynn, and some of the fantastic examples from Marta are really generating these amazing geometric freedoms that didn't exist in traditional manufacturing. And the reality is that there was a software is eating the world is a very famous quote if you haven't heard it, and certainly that isn't the case in manufacturing software as well. And I think one of the biggest challenges is the software can develop all sorts of very complicated geometries. The trick then is making sure that it is producible. And to take the analogy of photography, when I was using my projector in photography, I was always limited by my paper size. I could only get photographic paper up to a certain dimension, and that limitation exists today in 3D print technologies. There are very large printers in the meters dimensions, but for many people, that is one big limiting factor. And there's questions in the chat around materials and the development of materials, and all of these things really go into making these amazing, creative, complex geometries physical. And of course, there are these constraints that we do need to keep in mind in order to get from the cloud, the software cloud, into our hands. And some good examples from Marta around post-processing, and that is a very, very important part of designing, developing any component for printing, is what do you do after the print, because inevitably you have some other process. And so all of this goes into what is, in my opinion, the most important part of the process is what do I get out of it? Because fantastic animations and online renders and really good graphics. Personally, for me, what is really exciting is the physical good that we can develop at the end.
Thank you, Mitchell. With that in mind, we have some questions in the Q&A panel. What I might do is I'm just going to read out the questions, and any of you can take those questions. But if you don't mind, I just realized we are coming to time. So if you don't mind, keep the answers short and sweet so we can get to as many questions as possible. I really appreciate that. So the first one, is generative design the same topology optimization, or is it different? Could you evaluate it if it is different?
Yeah, I mean, maybe this one for me. I mean, no, it's not. Topology optimization starts with an existing object and then just removes all the material that is not necessary. And that's great. It's a great use case. It's kind of the cabin separator. Generative design can do this. I mean, you would probably use the term generative design also for topology optimization, but it's much more. I mean, like I said, what we are doing is we're creating objects completely from algorithms, and that's generative design. So we're not starting with an object and just trying to make it lighter. We're creating something from scratch using the material properties, the production process, all of that as input, and then we create something that fits. And so that's the huge difference.
Thank you, Lynn. The next question, what is your opinion on 3D print for the niche market? Do you think 3D print will benefit from economies of scale?
Yeah, I can take this one quite briefly. I'm looking further into this question, and there's a comment here around, the ultimate purpose of business, and the vision of HP is to make technology that makes life better for everyone, everywhere. That's HP's vision. So, this focus on price can often lead us down a path that isn't always the best thing for everyone. And where I think 3D print can add value is changing the design of the component. And if we really are 100% focused on super low price, then the traditional technologies typically would offer a lower price, but 3D print offers a much higher value. Some great examples from the team here around customization, lightweighting, etc. And certainly, those high value products are typically lower volume as well. So to answer the question, I do believe that there is opportunity for niche markets. And in fact, Marta's business is proof in point, I think, for exactly that.
That's right.
And another short answer here. I mean, if you're competing with your 3D printed object with traditional manufacturing, you've already lost usually, because that's already highly optimized. What you have to create is like what Marta is doing, objects that are novel, innovative, and do something new, and which can only be produced using additive manufacturing. And there's a gigantic space opening up there. And I think, in the next couple of years, we are going to see a lot of objects that you currently associate with traditional manufacturing methods, transition over to additive.
Lynn, actually, while I have you on the screen, the next question is for you. The helmet is a great case of how AM plus algorithmic generative design enables more rapid iterations and accelerates improvement in a product. First question, what are the main challenges preventing wider adoption?
Well, I mean, it's mostly economical, right? So, what we need to do is, just get more people on the table, at the table that work together, printer manufacturers, material manufacturers, etc. So, in the end, it's a question about economics, and some things are ready for that yet, and others are not yet. There's, of course, also challenges like materials and stuff like that for something that's as sensitive as a helmet. But fundamentally, I think a lot of these things are going to happen in the next couple of years. So, maybe some of them in the next couple of months already. So we are, with a lot of these use cases, at the stage where it makes sense economically and technically.
So then the next question is about those materials. How important a role would material innovation play in realizing generative design?
Yeah, critical. I mean, this is, for us, this is one of the most important parts of the physical product. How does it perform in a material way? And, HP was one of the first organizations to openly position material partners. So, for example, right now we work with BASF to produce an elastomeric material very specifically developed for a particular type of application. So, there are thousands of different materials and different types, and they all have their unique properties. The challenge right now is, how do you get all of those, or at least some of those materials, into a way that we can produce components additively? And this is where, we really have to be focused on what's going to add the most value to customers, and where will we get the most benefits of those materials. So the answer is, it's critical, a really important part.
So audience, just to let you know, I'm trying to pick at least one question from each of you. So those of you who have multiple questions, we may not have time to get to them, but I promise you to pick one. So the next one is, to my knowledge, generative designs are usually based off optimizing performance. Are there any use cases or benefits to generative design for aesthetic purposes or for art in 3D printing?
Yeah.
I think we have a good example here, right?
Yeah.
We have an example, yeah.
Weren't you listening? No, I'm kidding.
Yeah, I think for art, and especially for fashion, because we produce lots of fashion accessories, that plays a huge role. And especially when you can create the whole project. For example, when you claim, we create a series of bags. They're going to be exclusive. There's going to be only 100 of them. And can you imagine, each one of them is exclusive because it's different. It's got its own serial number, and the shape is slightly different. So in that way, customer becomes really interested in getting this product because it's only one-off. It's going to be another 99, but they're similar, they're not exactly the same. So for this purpose, generative design is very, very important, because imagine creating 100 bags by hand. That's going to take lots of resources, lots of time, and it's going to be a huge cost. But if you use this function, yeah, it makes it much faster, and it delivers an absolutely unique product to your customers.
But Serene actually had another great example that it's not just about individualization. It's really also about exploring designs that you may never actually have had the time to explore. So it's an incredibly creative tool. Absolutely.
Yeah, and they can also take care of things like the fluid behavior, the airflow in the building. All this could become your constraint. Yeah, the structural constraint that you have, you can put into the parameter, and you get the generative design to give you a different option for you to explore. So it's just not just about performance. You can also use that for aesthetic, and also can look at that from a performance requirement, from an airflow requirement, and your structural requirement. So you're finding the best design that you think are the best for your business.
It's like, imagine you go into the field, like beautiful summer field, lots of wildflowers, and you pick the most amazing bouquet and you put it, and it's one-off. You'll never pick the exact same one. Next time it's going to be slightly different. So that's exactly what it creates. So every new product, even though that's still a bouquet, it's slightly different. It's unique. So that's what it does. It's perfect for art.
And it's the design process becomes a little bit like botany, right? You're not designing something from scratch. You're just picking the flowers that you like, and you cross them and you create something new, and you direct them in a certain direction. It's an amazing process, and it has nothing to do with this drudgery of creating stuff manually. It's more like guiding the process.
No, so I think that sort of answers the next question as well, which is the role that humans play to automate more of the mundane design tasks. I think we got to the other question on scalability. We've also talked about design at scale, and we are perfectly on time. We're about 2 minutes late. So I want to say a big thank you to all our panelists. You've been amazing sports. Thank you for spending your valuable time with us. Marta, Lynn, Serene, Mitchell, it's been an absolute pleasure learning from you and spending this hour with you. Thank you also to the National Additive Manufacturing Innovation Cluster and the team at SGInnovate for bringing this session together. Wayman, hats off as always for organizing this. Thanks to the wonderful audience. I hope you all have a wonderful evening. Stay safe. Link up with our panelists if you want to ask them more questions, and I'm sure they'll be open to having a chat with you. Thank you, everyone.
Thank you, everybody.
Thank you.
Thank you.
Thanks.
Thanks, guys. Thanks, Suchi. Thanks, all the panelists. Thanks so much.
Thank you.
Thank you. Bye.
Bye.